Good morning, honors geometry students. This is Mr. Gallagher. This video is on a proof from 3-3, which is Cpctc and Circles. And this proof looks like this. There's a circle, and in that circle there's a diameter. And going through the diameter, through the center is another diameter with sort of a bow tie here. Like that. And around this is going to be KMOPR. So T and S are at the ends, T and S. And this is K. This is M, this point right here. This is O. This is P. This point right here is P, and this point right here is R. And this is what you're given. You're given two things, or three. One of them is you have a circle with the center at O. Now, what this means is, if you have a circle with a center, there's the center. So what that means right away is all the radii from that center are the same. There's those two, this one, and this one. All four of those segments are equal, because all radii are congruent. Now I'm going to take those highlights away. The next thing you're given in this problem is that angle T is complementary to angle MOT. And you are also given that angle S is complementary to angle POS. Now let's find these angles on the diagram. Let's look at these angles. Well, this is angle S, and this is angle T, and this is angle MOT, and this is angle POS right here. Those are vertical angles, so those are congruent. But we're going to state that in the proof. These are vertical angles. Okay, so we have to look, we looked at all four of these angles. That was good. We don't have to say anything about them right away, but we identified them in the diagram. In this problem, we have to prove that MO is congruent, segment MO is congruent to segment PO. Identify those two segments. That's right here and right here. So we've identified all those parts of the diagram. Okay? So now we need a two-column proof to try to get this done. So I think what we should do is put these two givens down and then make these two angles equal because they're vertical angles. Let's start there. See, angle MOT and angle POS, those are vertical angles, so we can get those congruent. And if you don't notice already, the two triangles we should be getting congruent in this problem those are these two triangles right here. There's this triangle, okay, and this triangle. So we have to get those two triangles congruent. But it's a process, so we're going to start off with the first statement, which is angle T, comp, angle MOT, and that's given. And step 2 would be angle S, comp, is complementary to angle POS. And that's given. And the third step is going to say that angle MOT is congruent to angle POS. Now, if you forgot already, these two angles here are vertical angles. So we can say vert angles congruent. Now, this brings back a fact from the last chapter. Okay, I'm just marking my vertical angles. This brings back a fact from the last chapter that says complements of congruent angles are congruent. Okay? So we can say that angle T is congruent to angle S, because comps of congruent angles are congruent. Now, we have angle T congruent to angle S. And I think we can get the two triangles congruent by angle, side, because of those two sides are radius of the circle, and angle. So in our proof, we have to get the radius of the circles, of the radii of the circle, congruent. So we're going to say that OT is congruent to OS. And that is all radii congruent. Okay, so that's good. Now we can put our tick marks up here, and now we can get the triangles congruent. So 6 is triangle MOT. I'm just using the angles up here. Congruent to triangle POS. And that is angle side angle. And let's figure out where those are. Where's the first angle of the two triangles? Well, I think that's 3 because vertical angles are congruent. Right there, step 3, see it? Now the side of the triangles are in step 5, the radii. And the other angle right there in the two triangles is going to be 4. Angle T congruent to angle S, which is here and here. Now, we did not have to prove the triangle's congruent. We had to prove MO is congruent to PO. But what you should notice is that here's PO and here's MO, the segments there, and they are part of the two triangles that I got congruent, and that is what Cpctc does. Corresponding parts of congruent triangles are congruent. So since the two triangles are congruent, their parts are congruent. I hope you can see here that if we have to prove, you see, MO is congruent to PO, and you see this MO right here and this PO right here in the two triangles, that's the same thing. That is the same thing. So we're done. Basically, we're going to use Cpctc. So MO congruent to PO. And that is Cpctc. Corresponding parts of congruent triangles are congruent. That basically means when two triangles are congruent in a proof, all 6 parts of their correspondence is congruent. So all 3 angles matched up and all 3 sides matched up. And we only needed three of those pairs out of the 6 to prove the triangle is congruent by angle side angle. All right. Be well. Take care.